So let's carry on with what we were doing in statistics. We've recapped the grade 11 stuff where we've spoken about the mean and standard deviation, box and whisker plots, the median, the quartiles, etc., etc., etc. So now what we really want to do is get into the matric stuff. So Emma Maleng, I think you need to log out and log back in again. Okay. Because you should be able to see the screen. Can everybody see my calculator on the screen as well?
Yes, we
Oh,
can see
good.
that.
All right. So you guys are going to need your calculators in order to be able to do this. All right, good. I'm glad you can see everything. So please get your calculators out. And we're going to answer the questions, or I'm going to show you how to use the calculator to determine the equation of the least squares regression line. Okay, so the first question here is they do ask us to calculate the equation of the least squares regression line. So the information that's been given to us is a group of 12 students from the 2016 trials examinations and corresponding NSC final examinations shown at the table below. Okay, so this was their trials mark, this is their final NSC mark, and there is a comparison between the two results. Okay, and the first thing that they ask us to do is to calculate the equation of the least squares regression line. So this is what I want to talk about this evening. Okay, so let's just move that up. We'll get this back. You've got to press the mode button. Choose option number 3 for statistics, and where we would choose option 1 for mean and standard deviation, now we are choosing option number 2. So you're going to press 2, and we need to put in the values. Now, matrix, the calculator is going to go away, but I'm going to call it back again. I just need to write on the screen. You can always treat the top row like that is your X's and the bottom row like that is your Y's. So what we want to do is fill in all our X values and then go back and put in all our Y values. So remember, after we enter something, we press enter. Okay, so 68, so you're going to enter all of these X values like I am. Please do this with me on your calculator. And make sure that you get the same values that I do at the end. Okay, I've got all my values in, so I'm just going to hang tight. Okay, so Amahle, you're going to press mode and then choose option 3 and then option 2, A plus BX. Okay. All right. So now once you've entered the X and the Y values, is everybody ready? You've entered your X and your Y values. You're all ready. Yes, Gugu says. Mamelo. All right. Tuelo. Thank you. Nandawa, thank you. Good. Okay, so everybody's ready now. So what we press now on our calculator is the AC button again. All right. So now we're going to press AC, shift 1. And now you're going to choose option number 5, matrix. REG stands for regression line. Okay, so we press 5. And if we want option number 1, which is the A value, sorry, it's gonna it's gonna go away. We press 1 and we press equals. Okay, so you guys are gonna press 1 and you're gonna press equals. And are you getting the same A value that I'm getting? Yeah, 28,15, quite right. Good, well done. So we're gonna write that down, 28,15. So A is equal to 28,15. Now we want the B value. So on your calculator, what you have to do now is go through the process again. So you've got to press AC, Shift 1, 5, and now you want option 2 equals. Okay, so 0,66. So B is equal to 0,66. Good. You will see on your formula sheet the equation of your least squares regression line is A plus BX. They do it like that. Okay, it's just the equation of a straight line. Okay, so now what we can do is we can say Y is equal to 28,15 plus 0,66 X. Okay, and then we have successfully answered question number 1. Let me just write here that this was 1.3.1. Okay, so that's how we calculate the equation of the least squares regression line. What is the least squares regression line? I mean, I've just calculated its equation, but what does it mean? What does the least squares regression line actually mean for us in terms of our data? Does anybody know that? We leave it just like that, Minenhle. That's the answer. We're going to talk about what it means now. Can you see it's out of 2 marks? So sometimes it's out of 3. If it's out of 3, they'll give you a mark on A and B and the equation. I think in this case, there would be a mark for that and then for that. Okay, so what is the equation of the least squares regression line? What does it mean for us? What are we actually trying to do here? Does anybody know? So the equation of the least squares regression line tries to minimize the distance between the points. So we're drawing a line essentially that best fits the data. Right, have you heard of that? A line of best fit? So it's a line that describes the data in the most accurate way possible, right? And we do this in order to be able to make predictions about the data. All right, so what they want us to do in the next question is they want us to draw the least squares regression line on the grid provided, okay? Now, we are not allowed to draw our least squares regression line outside of the data that's been given to us. Even though we can see what the y-intercept is, we cannot allow our graph to touch the y-axis. Sometimes it makes absolutely no sense for it to do that. But in this particular case, it would be okay, although it's not a result that we would want to see. But we can only use the equation of the least squares regression line to make predictions about the data between its smallest and its largest values. Outside of that, it's not reliable, okay, because we don't know anything about that data. So when you draw the equation of the least squares regression line, what you want to do is go and find your smallest x value. What is our smallest x value? It's 41. Does everybody see that? Our smallest X value is 41. Absolutely. Our largest X value is going to be this one over here, 94. Okay. So what we can do here is we can draw the least squares regression line between our smallest X and our biggest X, being careful not to go outside of that. All right, so I'm going to get a green line. You would obviously do it in black or blue ink. And what we want to do is connect, oopsie, let me just, there we go. And then let's just, oh no, man. Sorry, guys, this is the problem with doing things online. Not always. Okay, hang on. I don't like what it's doing here. Let's try that again. It wouldn't let me move it. Okay, all right. So kind of like that. Okay, so I want to connect those two together. All right, not going past my endpoints. All right, so that's really important. I'm not allowed to go past my endpoints, the smallest or the biggest. So that's question 1.3.2 done. Let's go and have a look at question 1.33. They want us to write down the correlation coefficient. So that is something else that we get from our calculator. I hope you guys haven't wiped off what was on your calculators. What we would do again is we would press AC, shift 1, go back to 5 for regression line. And now we're going to choose option number 3. So we're going to press 3 and we're going to press equals. And it gives us a correlation coefficient of 0.80. Okay. Does anybody know what the correlation coefficient tells us about the data? Yes. Okay, so you guys are on the right track here. There's a strong positive correlation. Good, absolutely. So it tells us how closely related the two sets of data are. So how closely related your trials examination is to your final NSC examination. So if there is a strong positive correlation, it means that I can use the equation of the least squares regression line to accurately predict what you would get in your final NSC exam if I had your trials exam results. Okay, so the closer it is to 1, the better the relationship between X and Y. Okay, so this would just be a strong positive correlation. It is not a very strong positive correlation. Okay, so now it says comment on the correlation between the trials exams and the NSC exams. That's what some of you were telling us. So here we would say a strong positive correlation. Okay, good, well done. So that's that one and that one. Let's just check on the number of marks here. 1 and 1, so we'd get 1 mark for each of these. Please mute. Please mute, thank you.
Yes,
and then,
sorry.
Thank you. No, that's all right. I think sometimes people don't realize. Okay, then in 1.3.5, it says a particular student scored 47% in the trials examination. Use the equation of the least squares regression line to predict, correct to 1 decimal place, the result he would have scored in the final NSC examination. All right, so now we are going to sub in. So we would say y equals 28,15 plus 0.66. Remember, our trials examination were our X values. So we're going to pop in the 47 over there, and then we're going to work out what Y is, what the corresponding y value would be. So now on your calculators, right, you'd obviously want to get out of all of this. So you could press mode, go back to option number 1, and now you're back to computing. All right, so now you can put in your 28. Sorry, let me just move. I just want to move the calculator over. Come, calculator. 28.15 plus 0.66. And then here we're going to put in 47 and press equals. And then we can press our SD button. Okay, so it would be 59,17. So that would be 59,2. Okay, so 59,2%. All right, now I see there was a question. Anthony, you had your hand up. Do you want to ask something, Anthony?
Hello, ma'am.
Hello, how are you?
I'm fine. How are you?
I'm fine, thank you.
Yes, ma'am. With 1.3.2, ma'am. You said
Yeah.
that like the line, we take the highest and the lowest, and then we connect, right? What if like our highest or our lowest is an outlier, ma'am? I mean, like how would we draw the line?
Okay, so in a situation like that, you wouldn't allow the least squares regression line to be affected by your outlier. I would be very surprised if either in your trials or in your final exams that they give you a value that would be considered an outlier. So yeah, it's not something that you would need to worry about. Still just work between the smallest and the biggest. Okay. All
Thank
right.
you.
No problem. Good question, Anthony. Very, very good question. Okay, and that's it. So 2, 4, 6, 8 marks. This should be something that is relatively straightforward and easy enough for us to be able to get. Any other questions? Okay. All right, so I've got one for you guys to try. Here you go. Let's just move this over. And I think what we'll do, this is a little bit more difficult than I had anticipated. Okay, let's put that over there, and then hopefully you can see everything. Okay, so you guys are going to try this question all the way from 1.2 0.1 to 1.2.5. Might be a little bit difficult for you to draw the equation of the least squares regression line, but we can certainly talk about that. And then again, you guys can, or actually, You can just say you're done when you're finished, and then we can mark it together. I was going to say DMing answers, but there's just too much here to DM answers. Yes, Emma Maleng, quite right. That's why I chose this question. Okay, remember your correlation coefficient can be between -1 and +1. So yes, in this case, you should be getting a negative. Okay, if you don't get a negative, something's wrong. Okay, so Gugu, I'll just write it here for you so that it's a little bit bigger. All right, so in 1.2.3, they give you the equation of the least squares regression line, and they say that it's equal to 1201,74 minus 9,6546 x. No problem, Gugu. Sure. There's the x-axis. It's an age in years. And on the y-axis is the amount of money spent on entertainment. Anthony? Okay, there's a whole lot of people that are done. Okay. All right, good. Now, with this particular, we're going to answer your question now. Anthony, that's not what I got, but I mean, maybe I made a mistake, but let's go through the answers together. Okay, so this question we can see is a little bit different from the one that we did before. All right, first of all, when we calculated the correlation coefficient, what did you guys get as a correlation coefficient in 1.2.1? What did you get? What did you end up with? Anybody willing to share their answer for R? Okay, me too. Okay, so negative 0.67. Okay, so what does this tell us about the data straight away? Good, well done. What does this tell us about the data? I mean, they're asking us that in 1.2.2 anyway. What does a correlation of negative 0.67 tell us about the data? Okay, so yes is a negative linear assertion. Yes. I like what Lindelwa, you've said it's unpredictable. Okay, why? Why is it unpredictable? Cheslin, you're right, the line does slope down. That's why it's got a negative association. Mamelo saying weak negative. Why is it unpredictable? Okay, so it's not a strong negative correlation, is it? It's a, yeah, could we say weak? I don't know if we could say that it's weak, but it's certainly not, it is very average. What other word could we use to describe that? Weak negative linear correlation. Moderate is a good word. Okay, so perhaps weak to moderate or moderate to weak. Moderate to weak. Negative correlation. Okay, good. Well done, Matrix. Okay, so we can see that there is not a strong relationship between someone's age and the amount of money that they spend. Why do you think that in this case, that the correlation is negative? What makes this correlation negative? What does that tell us about the data? Oh, Stokozile, it's not as simple as that. You're going to have to listen carefully when we do the next question. Okay. Why is there a negative correlation in this case? Yeah, this is not a strong correlation, Amahle. It is unpredictable. Okay, so between negative 0.3 and 0.3, it's considered weak. Yeah, that's why we said moderate to weak. Okay, or moderate, I suppose, but moderate to weak, I'm sure they would still give us the marks. Why is it negative, though? What does that mean? Why is there a negative correlation here? How is a negative correlation different to a positive correlation? What does the negative correlation mean? Does anybody know? So what it's telling us, Matrix, the reason that it is negative is because the older you get, the less you tend to spend on entertainment. So as age is getting bigger or increasing, so amount of money spent on entertainment is decreasing. Okay, does that make sense to everybody? Okay, that's quite right. If the one quantity increases, the other one decreases. Yes. So as a person gets older, or in the data here, as the people are getting older, so they are spending less and less on entertainment. That's why the gradient of the line is negative. Remember, the b value, the one in front of the x, tells us the gradient of the line. Okay, so negative 9,6546, as opposed to this gradient over here, this was bigger. So what this tells us is that if someone, as your trials exam mark, as if you tend to do well in trials, you should also do well in your NSC final exams. Okay, so the better you tend to do in trials, the better you tend to do in your NSC final exams as well. Okay, so that's the difference between a positive and a negative correlation. Right, in question 1.2.3, they give us the equation of the least squares regression line, and they tell us to predict, corrected 2 decimal places, how much a 55-year-old person would spend on entertainment. So what we would need to do, remember, age is our X value. We're going to substitute in 55 over here. And this is where I got a different answer to somebody who sent me an answer. I got 670,74. Okay, so that would be 670 Rand and 74 cents. That's what I calculated. Okay, Lesejo, got a different answer to you. Cheslin, I'm not sure where you got that 719,01 from. Everybody else we seem to be getting Zahir, Akila, Ibukhang, Imihle, Lendelwa, Mamelo, Emma Maleng. Okay, you also got 719,01. So Emma Maleng and Cheslin, I wonder what you guys are doing that's different to the rest of us. Oh, you subbed in wrong. Okay. Oh, they multiplied by 50 and not 55. Oh, thanks, Awami. You really are on the ball. Okay, that's it, Tuelo. Okay, so no, 670, 670. How comes 77? Okay, so let me do it on the calculator here. Okay, so let's just clear. Please mute. Thank you. 1,201. Please mute. Thank you. 0.74.
I'm muted.
Thank you. 9.6546 times 55 equals. Okay, so here as well, we're getting 670,74. There we go. Okay, so that's what we should be getting in this case. So 1 mark for subbing in and 1 mark for our answer. Okay, so correlation coefficient, they've given 2 marks to it in this case. That's fine. 1 mark here, 1 mark for subbing in, 1 mark on our answer. Now, they want us to draw the least squares regression line on the grid provided. Now, however, this is going to be very different. Oh, you didn't see. Oh, good, Tuelo. It was given to us, Chantal. Here in the question, it says, predict corrected 2 decimal places how much a 55-year-old person would have spent on entertainment. So that was given. Okay. Yes, Emma Maleng?
Ma'am, in terms of X, I have substituted 50 instead of 55. I just realized.
Okay. All right. So that's where you got that weird answer from. Okay. All right. So it was a 55-year-old person, not a 50-year-old person. Okay, so it was just subbing in the wrong value. Okay, all right. Now, in question 1.2.4, again, they want us to draw the least squares regression line. But if we just connect the smallest value to the biggest value, it's not going to be correct. Why not? Why is it not going to be correct for me to just connect? So if I did this, I'm going to show you now. If I did this, it would be wrong. Where's the biggest one? There. If I do that, That's not correct. Why not? Yes, absolutely. Correct, for a lot of reasons. Lebogang, yes. Okay, there's very little correlation. All right. They are all far apart. Can you see there are a whole lot of points that are way above up here? Okay, so this pink line would definitely not best fit the data in this case, right? So we've got a way around this, and it's actually not a difficult thing to do at all. We use the equation of the least squares regression line. So what we want to do, because remember, we're not allowed, you can't use the y-intercept in Tlantla. It's not because the y-intercept would lie outside of what we're working with here. Remember here, our smallest value was 15, our biggest x value was 75. Okay, so we can't extend smaller than 15. Okay, so we can't go past 15. We also can't go past 75. We have to be in between those two values. Okay, so Cheslin, you can't go outside of your smallest x and your biggest x, okay, because then it would not be reliable. Okay, we don't know what would happen with people that were younger than 15. And we also don't know that the data would follow the same trend for people outside of 75. So we can only make predictions using our least squares regression line on people between the ages of 15 and 75. So what we can do here is we can use the equation of the least squares regression line to find a value. So just inside of our minimum, which is 15, just inside of that would be 16. Okay, so what I'm going to do is I'm going to sub in, all right, so y equals 1201,74 minus 9,6546. I'm going to sub in 16, which is just a little bit bigger than my minimum. And I'm going to work out what y would be. So let's do that. You guys can share your answers. What are you guys getting? That's it. I'm also getting that. I'm getting 1047, comma, I'm getting 27 as my decimals. There we go. Good. Well done. And what we want is something that's just a little bit smaller than 75. So let's go with 74. So I'm just inside, or just bigger than my minimum and just smaller than my maximum. What do we get here? Do you get 487,30? There we go, lovely. Okay, so now what we want to do is we want to plot these 2 points. The 16 against the 104727. So we're going to find 16 here. So that would be 24. So 16 would be on this line here. And we want 1047. So that would be somewhere round about there. Okay, and then we want 74. 74 would be here. There's 74 against 487. So 4, It's going to be very close to this point here, 487. That would be somewhere round about there. Okay, and now we're going to get a pen and we are going to connect. Doesn't do it perfectly, but you would obviously connect your points like so. Okay, because we're not allowed to go past the minimum or past the maximum. That's fine. So Gugu, 16 is just bigger than our minimum. Okay, and 74 is just smaller than our maximum. So we don't want to go smaller than 15 or bigger than 75. We need to be in between these. Okay, so that's why I used 16 and 74. Because we want to draw the equation of the least squares regression line. Okay, so that's why we're doing this. Okay, in this set of data, our correlation coefficient is only negative 0.67. So there is not a strong correlation. So it's not going to be reliable for us to connect the smallest with the biggest. Okay, what we need is another way of being able to do it. Okay, because if we connected the smallest to the biggest, then we would ignore all of that data that is greater or above the line. All right, and we're not allowed to do that. So Chedison, we're not going to use any more points. We're just going to use those ones. Okay, just the 16 and the 74, because we just need 2 points to draw a straight line. Okay, and in fact, I mean, we would probably get pretty much the same thing here. We could do the same here as well if we wanted to. It'll give us the same result with this one. But if we went, what was our smallest? Our smallest value here was 41. If we choose 42, let's just see where that puts us in this one. Okay, so if we went y equals 28,15 plus 0.66 times 42, where would we be? $55.87 I'm getting. Are you guys also getting 55.87? That's it. Okay, so 42 would be there. 55.87, you see it's very close. 55.87, it's practically there. Okay, then with, and that's because your correlation coefficient is so much stronger. All right, if we go just inside the biggest one, what was the biggest X here? Was 94. So let's go with 93. So y equals 28,15 plus 0.6 times 93. We'd end up with are you guys getting 89.53? That's it. Okay, so 93 would be somewhere over here, and that correlates with 89.53. Okay, so just a slight difference in this case. Let's see. There we go. Yeah, no, it's pretty much exactly the same thing, okay, because our correlation coefficient was so much stronger. Okay, but with this one, it would be vastly different, okay, because of all of these points that are way above, way up here. Okay, Okay, so we've drawn the equation of the least squares regression line. We've answered question 1.2.4. Now in 1.2.5, explain why the prediction in question 1.2.3 may not be reliable. Okay, what's it down to? Why is it unreliable? It's got to do with our correlation coefficient. Okay, so it's because of our weak to moderate correlation coefficient. Okay, so the correlation coefficient, that tells us how strongly the data is related. Okay, so it's not because it's negative. Okay, it's because it's 0.67. Okay, so data can still be reliable. So in Tlantla, if the correlation coefficient was negative 0.91, it would be very strongly correlated. Okay, so it would be reliable. Okay, but it's because it's not close to -1. That's why it's unreliable. Okay, so the correlation coefficient is not strong. Okay, therefore the data is not reliable. All right, does that make sense to everybody? Okay, Lesejo. Okay, so having a negative correlation coefficient is fine. Okay, but the closer it is to -1, the more closely the data is related. Same story as if the correlation coefficient is close to +1. Whatever's been plotted on the x-axis is closely related to whatever is plotted on the y-axis. So we can see here, I mean, if we look at the data here, where we're comparing not really comparing, but we're talking about what you would get in your trials exam and what you would get in your final NSC exam. We expect these results to be closely related to one another. In fact, they say whatever you get for your trials exam, you will generally get around about 5% more for finals, more or less. So it's within 5%. Whereas, here they're comparing someone's age to how much money they spent on entertainment. We're not expecting X and Y to be as closely related. So it's like if I take your shoe size and I relate it to your IQ, we're going to see exactly what we get in the second question. We're not expecting those two things to be closely related to one another. Okay, whereas your trials exam and your final exam, we are expecting them to be closely related to each other. Okay, Emma Maleng, you had a question?
Yeah, ma'am, if our R is -0.5, is it reliable or not reliable?
No, not reliable. Not reliable, because then it's even further away from -1. So as you get closer to 0 from
Okay.
both sides, it becomes more unreliable. Okay, Emma Maleng? All right, so as your correlation coefficient gets closer to 0, the relationship between X and Y is less reliable or not as strong. Okay, any other questions? Okay, so we've only got 10 minutes left. Let's just see if we can fit in this question as well. Obviously, just depending on how time goes. All right, so the first thing that they want us to do, they've given us monthly income of 6 different people and the amount that they spend on the repayment of a motor vehicle. So let's see if we can work out the equation of the least squares regression line quickly. You guys work out what that is, and then you can share your answers with us. Is that the correlation coefficient that you've sent me, Lesejo? Yes, it must be. Okay, I'm getting the same correlation coefficient as you. Yes, I agree. That is the correlation coefficient I've got as well. Don't think we're going to have time to be able to finish this question, unfortunately. Okay, I'm getting the same correlation coefficient. What did you guys get as the equation of the least squares regression line? Have you got that? That's it, Mamelo, well done. So the independent variable would be your x variable. Good, Gugu. Good, am I there? Okay, so for your least squares regression line, that's it, well done. You should be getting what they've put in the chat. So negative 1946, 88 plus 0,41x. Lovely,
Nice.
well done.